Based company, been here since 1998. Our focus is on a completely different process. It's developing and operating integrated biorefineries that can convert multiple feedstocks and produce multiple biofuels. We're sort of the energy picks and shovels of the biofuels industry. Our core technology, shown on the left, is a flexible, versatile thermochemical conversion process for producing clean, controllable syngas, hydrogen, steam, and power in different mixtures from the same reformer. And our first integrated biorefinery is with RentTech, who's proven their FT technology for production of advanced drop-in diesel and jet fuel from wood waste, the gas, and mixtures of the two. We do have several other pathways. The top one is what we're going to focus on today. The second one is actually syngas with Coscata to make cellulosic ethanol. The third one is providing hydrogen, steam, and power to Amyris to go to diesel. And the fourth one we've completed with our EPC contractor, which is simply a reformer in a combined cycle mode to go to power, which has some efficiency advantages over standard wood-fired boiler. So why are we different? There's a lot of different gasifiers out there, all different kinds of designs for doing different things. We're different in that we're structured specifically for the biofuels industry. We can actually control the ratio of hydrogen to CO by changing the residence time in our reformer, which makes a matchup with other technologies a lot easier. Some of the things that help us out are in the designs listed here. So indirect firing is a different way to do it, where the combustion products don't mix with the gasification products, and you have more control over the kinetics. We use steam reformation rather than oxygen or air, so no oxygen plant, no dilution from the nitrogen, so that helps in our CapEx and OpEx. And then we also, as opposed to CFP or plasma gasifiers or other approaches, we actually use some of our own syngas to drive the energy for our process. And that means we can substitute out that with natural gas, biogas, or tail gas. So in the example with RentTech, they have a much lower value tail gas. We can send them all of our syngas and then use their tail gas to drive our process. And these are some of our partners. RentTech we mentioned, and URS and HydroChem. URS is our EPC contractor, HydroChem is our manufacturing partner. We've been working with these groups for the last 3.5 years, and through our demonstration, we started, when we first walked in to talk to these companies, we said, we want you to help us design our demonstration. So if it works to certain levels of performance, you can give us a limited performance guarantee for the first commercial plant, which is not an easy thing to do, but if you start early with the right partners, you can move in that direction. DOE, we'll talk about, we have a DOE grant. Hawaii Natural Energy Institute is a long-term partner of ours in technology development. And then some of the others are our local Alexander Baldwin, which runs the HCNS Sugar Mill, Hawaii Electric, and Ulupono Initiative. The one other important one I'd mention is BNP Paribas. They're our debt advisor for commercial development, and it helps to get one of those people in early. This is a pretty busy slide. I won't go through a lot of it other than to say we've been at this a long time. The top part of that blue curve is really the ClearFuel's gasification development through pilot testing and commercial design and so forth. The bottom curve is RentTech. They've gone through a series of different pilot scale projects sort of culminating in the PDU facility in Colorado. In 2009, after we had spent a lot of time with RentTech, they reviewed about 200 different gasification approaches and companies, and the combination of ClearFuels and RentTech came out about 30% higher yield than any other application because of the differences in design at a lower CapEx. So in 2009, they bought 25% of us. The next step is we combine forces to apply for a DOE grant for under the IDR project program, and that's sort of where we are today. So this is an aerial view of the RentTech facility. This facility has already taken natural gas, which is that small can on the left-hand side. I don't have a pointer here, which happens to also be built by hydrochem. It's a steam methane reformer. It takes natural gas, converts it to hydrogen and COs, and then it goes through the RentTech process to make waxes, and then that's integrated with UOP upgrader, so for hydrocracking and hydrotreating. So you end up with a mixture of carbon chains, which is what a lot of the engines like, rather than a single carbon chain, and so that they've got the fuel. This is RentTech. They've flown United Airlines jet around Denver Airport with fuel from that facility, and they've also manufactured renewable diesel, actually a synthetic diesel, and driven a bunch of Audi cars around California. So that part is proven, but of course it's coming from natural gas. It isn't renewable yet. So the next step is to take our hydrothermal reformer and put it in place of the SMR, and we are also going to make the hydrogen COs, goes through the same process and makes the same fuel. So that's what's happening. We should be done with that in 2011. Certification process, as we've heard, the FT process has already gone through certification, so we don't have to do that again. RentTech spent many years doing that with help from Kathy and others. And whether the feedstock comes from coal or nat gas or biomass, it's all the same process. Once you get the hydrogen and COs, it's the same downstream process. So we don't have to go through a recertification. We've got some risks, of course, in the demonstration. We think we've got the list of risks that we have to manage in order to be successful, at least to the point where we are also spending some money on commercial design. These are some of the plants that RentTech has done for the back end. The project size that we're looking at in that middle column is about 1,200 to 1,600 barrels a day. That's sort of the size we feel through our commercial research fits for the type of biomass plants that we want to build, and that relates to about 1,000 dry tons per day of biomass or biomass byproducts. A lot of us came from the IPP industry. We're pretty comfortable with energy infrastructure development. The three legs of the stool is a feedstock contract, an offtake contract, and an EPC contractor that will take the risk. Right now, financing is tough, but there are ways to do it. BNP Paribas, again, is working with us on all our contracts. And we do have some advantages because we're sort of focused on the energy side of the business. The first advantage is each one of our projects is co-located at either a sugar mill or a lumber mill. And so you've got a profitable operation that is bringing biomass to the site already, and there's enough waste products or byproducts from their operation right there at the site. So we don't have to develop a biomass feedstock supply chain. It's already there. That's one thing that's helped us out. Second is because we're on the energy side of the equation, we can develop an energy conversion contract with our partners. So some of the lumber mills that we're working with in the southeast are buying power off the grid, they're buying steam, and they're paying more for it. We can structure an energy conversion contract which actually just trades biomass for steam and power across the fence, and then the remaining biomass byproducts go to make the diesel or the jet fuel that we're talking about. So that's another way to strengthen the alignment between your partners, and that helps us in financing. The third piece that I'll just mention quickly is that because we're a modular construction, our standard design is about 250 tons per day. So for a commercial facility, we have 4 of those. There's a lot of reasons for doing that. It gives us more flexibility in operating them a little bit differently for the UOP upgrader than we do for the FT process. But it also allows us to, for example, put in the power plant structure first, get some cash flow operating, and then add the other modules later and finance for the actual fuels facility. So with that flexibility, we're not doing it all the same in all these projects, but but it does make it a little easier. So last slide, this is sort of our view of deployment of our technology. That middle line there are the 5 projects that we're talking about. So we expect the first one in late 2013. We've announced the Tennessee project at co-located East Hardwood and others along that chain. We're a firm believer that licensing of a technology doesn't happen until you've got a commercial plant up and proven. Then someone will pay for that license. We're maybe even being optimistic in that top curve comes off after commercial project number 1. It may actually come off after commercial project number 2. But at some point there, we feel we'll be able to license the combined technology of RentTech ClearFuels to developers who want to use other feedstocks besides bagasse and wood waste. We do feel that after we get through the demonstration, which is 2011, we will do some additional work with Amherst and Toscata and others in different integration of our technology with their pathways, and also for biomassa power. So that's all I have, and we're going to get ready for the last speaker, and then we'll go to some Q&A.